Imagine trying to sleep, but you can't lay down because there is no down. You can't put your head on a pillow because your head floats away. And if you don't strap yourself to the wall, you might wake up floating in the middle of the kitchen, or worse, jamming an air vent. Sleeping on Earth is easy. You close your eyes and wake up. Sleeping in space is a survival challenge. If the ventilation fans in your bedroom stop working for even 5 minutes, you won't wake up at all. You will suffocate in a bubble of your own breath. On the International Space Station, the crew lives in a perpetual state of freefall. Everything they know about rest, gravity, darkness, silence is gone. They are moving at 17,500 miles per hour, experiencing a sunrise every 90 minutes. So how do you get 8 hours of shut-eye in the machine that never stops screaming? Welcome to Space Facts. Let's turn out the lights. The first thing you notice in the crew quarters is that they are tiny, about the size of a telephone booth. There are no beds. Since there's no gravity, mattresses are useless. You don't need back support when your spine has no weight. In fact, many astronauts report that their backs stretch and elongate by up to 2 inches during sleep, which can actually be painful as the spinal column expands. Instead, astronauts sleep in sleeping bags that are tethered to the wall. It doesn't matter if the bag is vertical, horizontal, or upside down. It all feels the same. The real challenge is your head. Without gravity to pull it onto a pillow, your neck muscles relax and your head tends to flop forward onto your chest. To fix this, many astronauts use a Velcro head strap to gently secure their forehead to a cushion, simulating the feeling of laying down. Then there is the zombie pose. In microgravity, the muscles relax into the neutral body posture, arms floating up, knees bent. If you don't zip your arms inside the bag, you wake up with your hands floating in front of your face, looking like the unbed. The most critical part of the bedroom isn't the bag, it's the fan. On Earth, hot air rises. When you breathe out carbon dioxide, it is warm, so it naturally floats away from your face and is replaced by fresh, cool oxygen. This process is called thermal convection. In microgravity, convection stops working completely because there is no buoyancy. Hot air doesn't rise, it just sits there. If an astronaut sleeps in a room with no airflow, the carbon dioxide they exhale stays right in front of their mouth, forming a toxic, invisible bubble. They would essentially rebreathe their own waste gas all night. This leads to hypercapnia, a condition that starts with a splitting headache and increased heart rate and ends with unconsciousness. The loud, constant hum of the ventilation fans is the sound of survival. It physically pushes the CO2 bubble away and forces fresh oxygen into the sleep station. If the power goes out, the silence isn't peaceful. It's a deadly alarm that means you have minutes to wake up and move. You are watching Space Facts, where we explore the weird reality of life in orbit. If you want to know how they go to the bathroom or how they drink coffee, make sure to subscribe and hit the bell. Now, let's talk about the light show inside their eyes. Even with the lights off and their eyes closed, astronauts don't see total darkness. They often report seeing bright, sudden flashes of white or blue light streaking across their vision. These are cosmic rays, high-energy particles stripped from atoms during supernova explosions deep in the galaxy. On Earth, our thick atmosphere and magnetic field block most of these particles. But in orbit, the radiation passes right through the metal hull of the ship, right through the astronaut's closed eyelid, and physically strikes the retina or the optic nerve at the back of the eye. This triggers a phosphield, a false signal that the brain interprets as a flash of light. Some astronauts describe it as fairies dancing or pixelated fireworks. It's a constant nagging reminder that they are sleeping inside a radiation environment. Some astronauts have to sleep with thick, water-filled sleep masks just to try and dampen the radiation and ignore the light show happening inside their own skulls. Finally, there is the problem of time. The ISS circles the Earth every 90 minutes. This means the crew experiences 16 sunrises and 16 sunsets every single day. Their circadian rhythm, the primal body clock that tells you when to sleep and release hormones, gets completely confused. If they looked out the window, their bodies would never know when to release melatonin, leading to permanent jet lag. To fix this, NASA enforces a strict schedule based on UTC, Greenwich Mean Time. They also use solid-state lighting modules, SSLM. The station is fitted with special LED lights that change color temperature. In the morning, the lights are blue-white and intense to suppress melatonin and stimulate alertness. In the evening, the station shifts to a dim reddish-orange glow to trigger sleepiness. They have to trick their biology into believing it is nighttime, forcing a 24-hour rhythm onto a chaotic 90-minute world. Sleeping in space is a mix of camping and a medical experiment. You're zipped into a bag, strapped to a wall, listening to a fan that keeps you alive, while particles from supernovas shoot through your eyes. It isn't comfortable, but after a day of fixing toilets and conducting science in zero-G, it's the only rest you get. If this look at orbital insomnia kept you awake, hit that like button. Subscribe to Space Facts for more zero-G realities.